All right, so here's the demonstration. So say we call one function, right? And I don't know, this is just a code, right? And it creates an object. So it has like a stack frame here with the data on the stack that and it creates an object. And the object constructor is invoked. Then this function calls another function, right? So we make a function call into another function. It also creates its own stack frame somewhere here, right? And it also may create some other object right here. So it's just important to know that perhaps when the function returns, if this was a local object, it goes out of scope, right? As the whole stack frame goes out of scope and it's no longer available. So then I think in this picture I'm trying to say that when function calls are made and objects are instantiated locally inside the local scope of our functions, then the creation, the sequence of constructor calls and the corresponding destructor calls, which we will also discuss today, hopefully, is very predictable. Why is it useful? I may create an object such that it will print, its constructor could print a trace message and say, right here when the object is constructed, it could basically print a message saying, I don't know, entering a function. And by the way, by the time I return from a function back to its caller, the destructor of this object will be called, and I can safely say exiting function. So for instance, this very essence of very predictable sequence of how the calls into constructors as well as destructors is done can be used as a design pattern, right? So it could be, you can rely on this fact as a design pattern and basically then say, I can rely on the fact that constructor chain and of the sub-object constructors is very, very predictable. And you can rely on this fact as constructing, designing your objects. And I don't know how successful this example was, but essentially making a function call, creating an object, and using its constructor to print a debugging message. And then, sure enough, as soon as you exit and the object also has a destructor, it will show very appropriately, very predictably, a message to you that you're actually exiting this function, because this object goes out of scope and it was designed specifically to trace duration of your execution inside that function. So that's just some example that I can think of right now. So very important. The default constructor looks like this. The default constructor, if you want to define it, basically you use the same name for member of your use the same name for the member function as the name of your class. This is how your compiler will know that this is a constructor, in this case declared inside class, because it has the same name as the name of the class. And so then this is in a header file. Somewhere in the implementation file, you simply define it. You just say, okay, inside point class, there is a member function named point, and it does something useful. It initializes x and y coordinates of the point to 0. Makes sense. Now, by the way, if we didn't do it and someone created an object, x and y here will contain garbage. Unpredictable, something that by chance was in that memory. One curious part of the constructor syntax is that it doesn't have a return type, not even a void, nothing. This stems from the fact that if I go here and if I try to use a default in stack, in our case example, of stack 1, I don't know, something like that. The default constructor here is invoked because there are no parameters. The reason why there is no even a void return is that if allowed, let's demonstrate here for a second. If somehow we allowed to return a void, specify, oh, this constructor doesn't return anything, or we allowed it to return an integer. Strangely, this would make more sense. Okay, let's allow our constructors to return something back to the caller. Well, look at this constructor. I'm sorry. This was supposed to be demonstrated in the header file, where we declare the default constructor and then the specific constructor. What if I was able to return a value from a constructor? And likewise over here, I would then say, return 0, and that would indicate a success of some sort, right? Makes sense. Like constructor does something useful and then indicates back everything is good by returning 0. So, but look at this main function. If this is the way I declare a variable of this type in stack, user-defined type, there is no place to accept the return value. There is simply no syntax. You cannot say like, int x, right? And then say int stack x equals st1. If you're doing something like that, that means that you're declaring variable x. There's no syntax to accept the return value from a constructor. And it's done on purpose, and we'll talk about it. So simply put, constructors do not have, let me kind of remove this garbage attempts here from the original code. Save everything. And here go also back to the original proposition of just the way it was originally, is that constructors cannot return back any values, anything. Right, and it's not part of syntax at all. So and if I go back to our slide here, again, there's another type of object demonstrated here. The syntax looks very much like another member function, but there is nothing in place of a return value. There's no return value at all, and the purpose is that there is no syntax to even accept that return value. But not even a void is allowed. And it's just the way it is. All right. So if we said this is a default constructor which doesn't require default parameters, and then therefore it allows us to construct our objects just like this, just as we were able to say int x, right? Similarly, int stack st1. Okay, the object got created. So hopefully there is a default constructor which will do something. By the way, what is this environment I'm happy about? Let me try to build it and see if I have any problems there. Okay, fine. So it was. I can disregard that. Everything's okay. So moving on. Other constructors, other than default constructor, you can have other constructors. For example, for a point, it would be useful to have yet another constructor, which in its implementation file also defines this constructor and basically says, okay, let's initialize mx and my with some initial parameters. This we would typically refer to as specific constructor, because it takes a specific set of input parameters and does that specific initialization right here, which is appropriate when the user wants to use those parameters to create an object. So I can say point pt open parentheses 1020 and use it use this particular version of the constructor. Obviously, constructor, as other functions, can be an overloaded function, which it is, which it often is. Some rules here. Let me see if I can make it all visible. It says you will. So if for instance, if I did not define the default constructor right here, right? This is the default constructor of our instack class, and right here it was declared. So if this is gone, it's not there. Well, guess what? As soon as you create any constructor, the default constructor is taken away. It's no longer provided automatically. So if I temporarily comment this out and say, no, there will be no default constructor for this object, I can no longer construct my objects like this. I have to use a specific constructor, because the default constructor is gone as soon as I create any other constructor. It's just the rule, by definition. That's the behavior. If I didn't define any constructors, then the compiler will supply the default constructor implicitly. And that's what this slide refers to, implicit default constructor, which is supplied by the compiler, which means that you can, construct an object with no parameters. But you lose it in those three cases. If you add a constructor taking no arguments, basically you're replacing default constructor with your own constructor. That makes sense. Next, you also lose, let me check the timing on this. Okay. You also lose the default constructor as soon as you provide a constructor with particular set of parameters, including default arguments. I didn't talk about it, but we will talk about it pretty soon. And if you add a constructor that takes one or more arguments, so default arguments versus specific arguments, it's pretty much almost the same thing. So as soon as you start to define your own constructors, the default constructor is gone, and the implicit one, the implicit default constructor supplied automatically, is gone, and so you have to add it on your own. That's not actually a bad idea. That's okay. It's not a terrible limitation. Now, you must have a default constructor, not just when you simply want to be able to construct objects by saying, okay, the type of object and st1 and name it. But you also must define a default constructor if you want to say something like this, st array, and create 100 of these objects, right? Similar to how I was able to construct an array of integers, just like that, I can create an array of objects and specify how many I want. That's the same syntax. You specify what type of data you want, and then give it a name, and then say how many you want. In this case, a default constructor is invoked for every single one of them. Okay. So in that case, in order to create arrays, you must somehow define it and supply a default constructor. So let me actually get rid of these comments, because now we're basically back to where we started. So again, I made some of these little changes here. Let me just make sure that if I build, the compiler is happy and I'm not misleading anyone. So there it says no appropriate default constructor available. Did I mess it up? Oh yeah, I still didn't uncomment this. So try again. Okay. All right, so it builds fine. So let's save this.